Before moving on, I do want to touch base on, I forgot to write in 2 pi in the unit circle. But remember, for all of these angles, we can do any revolution we want. We can do a revolution like 13 pi over 6 and solve the problem once we do that. Full revolution, then pi over 6 more. So we can find the trig functions of any of these having this unit circle memorized. And then the next thing I want to touch base on is what is really going on as we look at these. Because theta is the angle made with the x-axis. Here's your right angle. And for simplicity's sake, in the unit circle, I guess I need to be careful because the radius could change, but we're going to be dealing with just a unit circle, so the radius is just 1. Because in geometry, and in the first unit that we started talking about this, sine was defined as the opposite over the hypotenuse. Well, if we were to look at this in the unit circle, we have the x-coordinate, we have the y-coordinate. Well, opposite of the angle is the y-coordinate. So it's y divided by the hypotenuse, which is the radius of the circle. But again, for our purposes, the radius is just 1, so y divided by 1 means y. Same thing with cosine. Cosine would be adjacent over hypotenuse. The old school way of doing this. Well, what's adjacent to theta? It's always made with the x-axis over r, the hypotenuse. Well, for our purposes, r is 1, so that means it's just the x-coordinate. And then tangent is opposite over adjacent, which leaves us with y over x. And so what this boils down to is that as we're looking at this, any point on the unit circle, as long as we're talking about the unit circle, we could say it's the cosine of theta is the x-coordinate, sine of theta is the y-coordinate, and anytime we're asked for tangent, we could define tangent as sine over cosine. And these are big, very important things as we move forward. So remember our kind of old definition of cosecant would have been 1 over sine. Or you could write it as hypotenuse over opposite, but what we're trying to get at though is it's 1 over y. Same thing with secant, it would be 1 over cosine, and then cotangent is going to be x over y, or you can think of that as cosine over sine. So how are we getting to this? Is in the first quadrant, everything is positive. And I could go back and I could point that out. Everything is positive in the first quadrant. But as we get to the second quadrant, only the x-coordinate was negative in the second quadrant. Well, let's review. Which trig function involves the x-coordinate? Cosine. So cosine is negative in the second quadrant. Okay. As we get to the third quadrant, both coordinates are negative. So cosine and sine are negative. And then in the fourth quadrant, the y-coordinate is negative, so sine is negative and cosine is positive. So we have a little acronym for students to remember, or I don't know if it's acronym is right, but what I've heard is all students take calculus. Imagine we're going through the 4 quadrants. And we're looking at the letters A, S, T, and C. So what I'm talking about is all trig functions are positive in the first quadrant. Sine is positive in the second quadrant. Cosine and tangent are negative. If you're confused by that, well, if cosine's negative and tangent is sine over cosine, well, a positive over a negative is still negative. Well, in the third quadrant, tangent is positive. And let's review, because both x and y coordinates are negative, so sine is negative and cosine is negative. Well, what happens if we have a negative over a negative? We get a positive. And then over here, cosine is the positive one. Now, this acronym does not even consider these three, but remember, these three are just reciprocal functions. So if sine is positive, then cosecant is positive. If secant is positive, that means cosine is positive. I said that backwards. But and then if tangent is positive, cotangent is positive as well. I've heard other acronyms, by the way, like Alvin, Simon, Theodore, Chipmunks. I don't really want to say the other ones that my students have come up with, but I'm sure you could Google different things, or you just memorize this unit circle, but that's a quick way to reference each one of those. So how is that helpful? Well, we've talked at a decent length, I would say, about reference angles. So just think about 3 pi over 4's reference angle is just pi over 4. So if it helps, just think about, okay, well, pi over 4 is over here. That's the root 2 over 2, root 2 over 2. So if I go into the second quadrant where 3 pi over 4 is, well, sine is still positive there. So we have a positive answer, and it's the y-coordinate of the angle, 3 pi over 4, so it's still root 2 over 2. And that is your answer, without looking at the unit circle. So the same thing goes with this one. The only thing is we have to add after we're done. So on the unit circle, pi over 4 and pi over 4, they share the same reference angle, which I already wrote down. Well, 3 pi over 4 is in this quadrant, and cosine is negative. So cosine, the x-coordinate, is negative in that. And then 7 pi over 4, okay, that's in the fourth quadrant, where sine is also negative. Same reference angle. Well, we can add them together. That would be negative 2 root 2. Denominators are the same. They stay the same over 2. So that answer is just negative root 2. There you go. Sorry, I went into the next one. But tangent. Okay, pi over 6. Over here, that is root 3 over 2, comma 1/2. Well, tangent, by definition, is sine over cosine. So it's the sine coordinate over a cosine coordinate, y over x. Oh, well, we're dividing by a fraction, so I'm going to multiply by the reciprocal. And then those 2's will cancel. Hopefully that makes sense. And then we rationalize that denominator, root 3 over 3. Please let me know if you are struggling to rationalize denominators. By the way, as we get more practice, I do anticipate you guys noticing if the denominators are the same and you're dividing. This only works if the denominators are the same. So it doesn't work if the numerators are the same. You can actually just cancel those out and 1 over root 3 then rationalize. But you'll do a lot of those in these. Okay, so more practice. Okay, 7 pi over 6. All right, where is 7 pi over 6? It's over here. Okay, well, tangent is positive in the third quadrant. Remember, all students take calculus. Tangent, positive. So what's the reference angle? Reference angle is back into the first quadrant, pi over 6. Oh, well, that's the same answer that we got over here. So this answer is also root 3 over 3. Yeah, pretty straightforward. Moving over to secant. Okay, well, 11 pi over 6, we're over here. Secant's reciprocal is cosine. So if it helps, you can rewrite this as 1 over cosine of 11 pi over 6. I don't typically do this, but you might. So that's the reference angle. Root 3 over 2, 1/2, except we're in the fourth quadrant, so maybe you write out negative 1/2. So the way I think of this is just, okay, well, secant is a reciprocal of cosine, so I want the x-coordinate, but what I need is the reciprocal. So 2 over root 3, just flip it, and then rationalize that denominator, 2 root 3 over 3. Oh yeah, I could do these problems all day. It's just going to take you a while before you get used to this. I'm not a big fan of this problem either, because I would reduce that the very first thing, and that's 1 over sine of 2 pi. Well, that might be a red flag for you, because if you think of the unit circle, I mean, I still have this other thing, but I have a red flag going up. Well, 2 pi is a full revolution. That's the ordered pair 1, 0. Sine is the y-coordinate. We can't divide by 0. That thing is undefined. Well, how can you add an undefined thing to anything else? You can't. So that answer is just undefined. Just more practice. We can also go clockwise. But remember, the reference angle is still pi over 3. So if you think of it this way as the ordered pair 1/2 root 3 over 2, and just think, oh, well, if I'm clockwise, because it's a negative angle, 2 pi over 3 would be down here, sine is still the y-coordinate, so it's just negative root 3 over 2. So we're in the third quadrant there. Again, I'm just thinking about this as, okay, so we're going clockwise. Okay, big deal. 4 pi over 2 would be a full revolution, so one more after that. That's the ordered pair 0, negative 1. And tangent is sine over cosine, or it's y over x. And I fully anticipate you might need this chart. It might take you a while before you're used to it. But again, what this boils down to is negative 1 divided by 0, which is undefined. We cannot divide by 0. And yeah, more practice. Just thinking about, okay, well, cosine if we're going clockwise because of the negative angle. All right, cool. So cosine's the x-coordinate. That's negative 1. So negative 2 times negative 1 will give me positive 2. I don't know if I need to write all this out for you. So we get negative 2 times negative 1. And then cotangent, we're going clockwise. I always like pi over 4 because who cares, which one's positive, or which one. Like, you just have to know what quadrant you're in, that the x-coordinate is positive, the y-coordinate is negative, but they're the same value when you have pi over 4. Okay, so cotangent is cosine over sine. And, well, when you divide something by itself, you're going to get 1. The only thing is it's a negative 1. So 2 plus negative 1, we're going to get 1 for that answer. And, yeah, I think I'm going to make one more video because I don't want to rush through the last thing. This is going to take some practice. I realize that. You're not going to get it right away. I do also want to point out that when I share the answer key, you'll see that the answer key does not rationalize the denominators. And some math teachers are fine with it. If you actually take AP Calculus, there's a lot of times that they will not rationalize the denominator. But in case your college professors expect you to, I want to at least touch base on that. Anyway, I'll see you in the next video.